Hello there, children. Today, we are going to work on factoring, which is the difference of squares. Now, what does that look like for all of you? Well, let's take a peek at that. So, where does this fit in all of our information? Let's take a peek. So, we were factoring quadratics. Now, as of the other day, remember the first thing we are supposed to do is factor the GCF. We are always wanting to go after a GCF. Now, difference of squares, that lies here. After you try to pull out a GCF, you then look at how many terms are in a polynomial. If there are two terms in a polynomial, that is for folks, we are going to concentrate on the difference of squares today. As we talked about, 3 terms and 4 terms will come later. So just take all that in. Alright, let us look at what this is going to look like with a formula. So let's take a peek at this. Here is the formula we need. The difference of squares is literally what it sounds like. Something squared minus something else squared. We factor it like this. A squared minus b squared in one binomial, and a squared plus b squared in another binomial. Note something here in this entire lesson. There is no sum of squares, folks. Let me be very clear. There is no sum of squares. We only have the difference of squares. If this were a plus sign, I can't factor it like this. So let that soak in. Alright, here is why this formula is the way it is. So let's take a peek here. If I have a squared minus b squared, I'm telling you this is the formula, where we have just a minus b and a plus b. Here's why. If you're not sure, when in doubt, you FOIL it out. So FOIL, remember, our wonderful way to distribute binomials. First term times first term, a times a squared. The outside two things, a times positive b, ab. The I, the inside, negative b times a, negative ba, or negative ab. And last, negative b times b, that's negative b squared. Well, look at that. The O and the I part of FOIL, that gooey nougaty center, cancels out. So we're left with this product, which is why this formula works. So what does this look like for us? Well, given a problem, the first question you should always ask, like this, an example here, x squared minus 9. Is there a GCF? And you go, yeah, it's 1. Well, that doesn't help us. If there is not a GCF other than 1, we now look at how many terms we have in this polynomial. Well, there are 2 terms in this polynomial. Immediately you think difference of squares. So I look and I ask myself, if this is supposed to be a squared and that's supposed to be b squared, I need to find out what a and b happen to be in this problem. So I ask myself, what times itself gets me x squared? Let me think about that for a second. And I answer, the answer is x. And I ask, what times itself gives me 9? Think about that for a second. The answer is 3. Then, since there is a difference between here, I then can factor it using my formula. Does it matter what order I put these in terms of having the plus or minus first? No. No, it doesn't. Doesn't matter at all. So that's good. There we go. If you're concerned about doing this right, FOIL it out. First, x squared, outside, 3x, inside, negative 3x, and lastly, negative 9. The gooey nougaty center of FOIL goes away, and I'm left with x squared minus 9. Moving on. Let's try this one. Alright, is there a GCF here other than 1? And you go, no. Okay. How many terms do I have? 1, 2. Okay, that should get you a little excited. So how do I factor a two-term polynomial? Is there a difference in between here? The answer is yes. So I check difference of squares. So I ask myself, alright, what times itself gets me y squared? And the answer is y. And you ask, what times itself gets me 81? Think about that for a second. The answer is 9. Then I simply put it into the formula. This time I'll put the plus first. Why? Because I can. And when in doubt, you FOIL it out. You FOIL it out. Woo! It's that simple, folks. Let's move on. Okay, let's look at this problem in all its glory. Wow. Is there a GCF here? Think about this. Well, no, there's nothing they both have in common. Alright, this looks a little tougher because there's a coefficient out in front here. And look, there's a 2-term polynomial with a subtraction in the middle. I'm thinking difference of squares again. But it's not as simple as it was. So let me ask you something. What times itself gets me 4x squared, if there is anything? Well, what times x gets me x squared? So, well, that's just x. What times itself gets me 4? 2. Now, let's look what times itself gets me 121. Think about that for a second. 11. Now we put these into binomials. 2x minus 11, 2x plus 11. Done deal, folks. That's okay that this is negative and plus. It could be plus or negative, doesn't matter. As long as you have it there, one being negative, one being positive, you're fine. Alright, let's try another one of these. Alright, folks, now down to the home stretch. Again, I have a 2-term polynomial here with subtraction in the middle. Alright, that means difference of squares. And so what times itself gets me 3? Oh. Whoa. Whoa, whoa, whoa. Nothing. Oh, man. Did I mess this problem up? Mr. Faust, sir? Yes, imaginary voice. You didn't check for a GCF first. Oh, how could I forget? Well, imaginary voice, I got some bad news. There's an x squared here, but no x's over there, buddy, so there's not an x. But sir, you can pull out a 3 out of both of them. Oh, you're right. I can pull a 3 out of both of these. Alright. What times 3 gets me 48, or negative 48? Negative 16. Wow! Now look, there's the difference of squares. Folks, remember how we always talk about pulling out a GCF is super important? Well, if you don't do it here, you're not going to notice that this actually is a hidden version of the difference of squares. Thank you, imaginary voice in my head. No problem. So, now, how do I factor this? Well, what times itself gets me x squared? Well, just an x. What times itself gets me 16? 4. Now, it's very important. You need to keep the 3 out in front of the whole problem. You can't just get rid of it. If you do, this won't be correct. How you would check it, you would FOIL over here, getting back to this, distribute the 3 in to get back to this. You are now more than capable of being successful in this lesson. Go henceforth and do.